The quickest way of showing how to use multiprocessing is to run a simple function without blocking the main program. In this case, my simple function only prints when it's starting, it sleeps for 1 second, and it prints when it's finishing. Now you see in the main block of code, I create a new process. The target is the simple function. I start the process. I print that I'm waiting for the function to end, and then I join this process. So you see, first I wait for the function to end, then it prints that the function is starting, and then that is finishing. It is important to note that we first print waiting, and then we print starting. This is happening because start, it's taking a little while to execute. Starting a new process is time consuming, and therefore first we print this, and then actually the function runs. To get a bit more of insight on how this is working, we can print something before defining the function. And this is very interesting because now we have this print statement. This was expected. It's the first thing our program does. This is what we had before, waiting. But then we see again, before defining simple func, and then we see the remaining output. This means that there is a piece of the code which is being executed twice. Now we see that this is what we expected. Before defining appears only once, and then the rest, it's exactly the same. This does not look like much, except for the second before defining simple func, and this difference is crucial. On Linux, when you start a child process, it is forked. It means that the child process inherits the memory state of the parent process. On Windows, and also by default on Mac, processes are spawned. It means that a new interpreter starts and the code reruns. That's why we get twice this print. Something that is incredibly important to point out is what happens if we use multiprocessing without this if name equal main. On Linux, we get no problems. On Windows, we get a very long error message. This error message is hard to interpret, but there is one line that points immediately to the problem if you know what you are looking for. You are not using fork. This will happen both on Windows and on Mac. And this basically means that our program is trying to import itself over and over again. It runs from top to bottom until it reaches the process. Once it reaches the process, it will try to import itself and it will reach the process, and then it will try again. And this gives rise to the error message we saw. So let's see another case. Imagine that instead of printing, we define a variable, val, that then it's used by our simple function. It just prints the value of val. Now pay attention in our code. We run first this simple function, which will print val, and then we create a child process just to run simple func again. On Windows, we get following output. And you see that it's giving two different values. On Linux, on the other hand, you see that the values are exactly the same. We can see a bit more sophisticated example if we work with classes. In this case, my class will create a new file. We can create a very simple method that prints, this is a simple method, and then it prints the value of I. We can also create a multiprocessing simple method that basically creates a child process just to run simple method, and then it starts. And to be completely consistent, we can create a method wait that will wait until the process finishes and then it closes the file. Since we are using multiprocessing, we know that we have to add this if name equal main. We create the class, we run the multiprocessing simple method, and then we wait. If we run this program on Linux, there is no problem. However, if we try to run this on Windows, we'll get a very long error message again. And it's very hard to understand what is going wrong until you see here, forking pickler, and then it says cannot serialize text IO wrapper. And this is already pointing to one of the core differences between Linux and Windows. The way spawning works is by picking the entire object. Therefore, if we have a class or an attribute that it's not pickable, we will not be able to start a child process with it. The interesting thing is that it does not matter how much you try to make this program multiprocessing safe by implementing locks or anything else, the root problem is at a much lower level. Now, if you wonder, is there a way of solving it? The answer is partially. We can add this extra line, set start method to spawn, and what will happen is that now on Linux, the program will give exactly the same error than we are getting on Windows. So is it solving it? No, but at least we have the same behavior on both operating systems.